Alright guys, this is Mr. Insunza with you doing the second part of that problem that Mr. McCaffrey started, which was problem number 5. We're going to do the last two parts together and see what we come up with. So here we go. Follow me right to my board. Over here we have 3 to the, this whole thing is your exponent, 3 to the 9 minus x power equals 81. Now, sitting there thinking, oh, well, we can do several things. McCaffrey's in the background trying to make me laugh, saying, never mind. Alright, so we have 3 to the 9 minus x power equals 81. So if we look at this, the first thing that comes to my mind is, this is an 81. And I know that 9 times 9 is 81. And so I know that 3 goes into 9, 3 times 3. So I'm thinking, you know what? I can actually break this down into 3 to the 4th power. Because 3 to the 4th power would give you 81. Now, just like before, that's one way to do this problem. But remember, there's a lot of different ways to do it. So, for example, well, I don't know about a lot, but there's other ways to do it. Like, for example, we could, if you want to, take the log base 3 of both sides and go in that route. But I'm just going to go this route because since I make the bases the same, you know, we can go ahead and solve it. So here we go. So this side, I'm not going to do anything to yet. But this side, I'm going to go ahead and rewrite it as 3 to the 4th power. And the reason I'm doing that is because, now look what we have here. 3, and that's 3. So this is my 1 to 1. Well, not really 1 to 1, that's actually for logs, but whatever. So this one right here, since both of these bases are the same, what you're saying is that, well, what does this and this, they have to be equal to each other, right? So your bases are the same, we get rid of them, so we end up with 9 minus x is equal to 4. And then if you think about it logically, you should say, you should think in your mind, well, let's see, since both of these are 3's, you know that this and this have to be the same, so you're saying, okay, well what does x have to be so that this power becomes 4? So that's why we set this up. That's what we're trying to do. Okay, so now all this is just a simple two-step algebraic equation that you learned a long time ago, so let's go through with it. We want the x all alone, so we subtract 9 from both sides. So we end up with negative x equals 4 minus 9, which is a negative 5. So now we have negative x equals negative 5. Now we want x all alone. There's that negative guy right there messing it up. So let's get rid of him. This is like if it was a negative 1. So to get rid of a negative 1, you can divide both sides by negative 1, and look what happens. Boom, that becomes a 1. So we end up with x equals a negative divided by a negative is a positive. Positive 5. There it is. Now, let's go ahead over here now and do the next one. So, alright, so for this one was 5, right? And think about it. 9 minus 5 is 4. 9 minus 5 is 4, so 3 to the... Oh, look at that. So, you didn't really... Well, you get the idea. So let's go over here. Now, this problem right here is very similar to this one over here, because this is a 2 here. This is a 1 over 8. However, the 8, we can actually rewrite it as a multiples of 2, as a power of 2 to some power. So, let's see, let's rewrite this. This is the same as 1 over 2 to the 3rd to the x minus power equals. Now, if you will notice this and this, they're not the same. So we cannot say, oh, these guys, we're just going to set the exponents equal to each other and then we're going to solve it. You can't do that because they're not exactly the same. So we got to take this number and move it to the top so that they're both actually 2's. And remember that when we move the denominator to the top, it becomes a negative. So here we go. So this is actually 2 to the negative 3 power will give you this number right here. But look, all of this is being raised to that power, so you got to remember to multiply that. Now, just like in the other problem, this is a 2, that's a 2. So if we find out somehow what the x values are, then we'll know they're going to be exactly the same. So we're going to eliminate those two, and we end up with negative 3 times x minus 3 is equal to 5x minus 4. Now all we have is a simple algebraic equation that we can work out and gives us our answers. So let's see what that is. Distribute. We apply the distributive property. Negative 3 times x, negative 3x. Negative times a negative is a positive. Now I'm going to go ahead and add 3x to both sides. So I end up with 9 equals 8x minus 4. And now, remember, we want the x all alone. So I'm going to go ahead and add 4 to both sides. So we get 8x is equal to 9 plus 4, which is 13. And now we just simply divide by the 8, and x equals 13 over 8. I know, this one, the answer came out a little crazy. It's a little ugly fraction, but it is what, that's what it is. I mean, so there's our answer. So there's the problem number 5 completed. So do your corrections, work hard at it, and if you don't understand something, or you want to take a different approach to solving the same problem, go ahead and come with questions if you need them.